This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a really full docket. Number one, we'll talk about Vestas and the recent cybersecurity incident. It's a scary thing for all businesses all around the world. So we'll talk about what that meant for them and if they're back up and running. We'll talk about Siemens Energy. Their CEO has mentioned that Siemens Gamesa is doing well, progressing in their turnaround, and whether we could expect a complete takeover from whether they finish buying the rest of their shares. They own about 67% of the company now. Let's talk about Shell. They've snapped up a majority stake in another offshore wind project off of Ireland. In North Dakota, some high winds have shut down wind turbines, which we know that this happens, but it's still always a curious event when it does. Wind speeds up to 70 miles per hour in that case. We'll talk about some unexploded mines from past wars, just lurking in the North Sea, and Rovco's drones, which are trying to help locate them. We'll talk about microgrids, the NREL energy storage modeling, some interesting stuff there. We'll talk about more supply chain crisis, whether that's going to continue to really affect the transition to clean energy. And lastly, we'll talk about artificial seaweed power. Is this the next big thing? I'm sure Rosemary's got strong feelings there. Spoiler alert, it's probably not. But before we get going, be sure to subscribe to the podcast in general. You'll also find Uptime Tech News, our weekly email update about the show, and great news from around the web. And be sure to subscribe to Rosemary's YouTube channel, which you'll find in the show notes and description as well. She's been doing live streams and all of her regular content on everything renewables and wind energy. So let's get started. Obviously, cybersecurity is on everyone's front of mind nowadays. It seems like every other week there's another company that's been hit hard. This week it's been Vestas. But there still seems like a little bit mum is the word at the moment. They have mentioned that their crisis management team is on it. And besides that, I'm not really sure what the extent of and what's happened. Alan, what's your take here? Obviously, there's not a lot of information that we've found in the news cycle yet, but it sounds like maybe Vestas is okay.
Yeah, it didn't sound like they were in a hostage situation where everything gets locked out and then you have to pay a ransom. It didn't sound like that, did it? Not that they would announce that.
No, it didn't.
Yeah, but it does sound like files got infected and they caught it maybe a little bit too late, 'cause it seemed to spread around the different manufacturing facilities they had and the different offices that they had. The question that popped up early was, does this affect operations of Vestas wind turbines? Did it get all the way out to the turbines? And the answer to that was no. So it's just an operational manufacturing issue, which is huge, right? Because pretty much everything today in a modern office complex or manufacturing facility runs on the internet, from the phones to obviously the computers to cell phones. Pretty much everything in the factory is running wide open on the internet. So if you get a bug or a virus...
Well, let me stop you there. Vestas's carrier pigeon division was completely unaffected. Completely unaffected.
Yes, genius. That fallback plan is just put into action, right? Yeah. So do you think that they're going to learn from this though at the moment? Because my guess is that they had a plan for this not to occur. So there was a breach somewhere in the system.
I mean, I think with a lot of these things, it does sound like this wasn't that big of a deal, because it said they shut down computer systems to try to prevent it from spreading. So it almost seems, I would guess, and I mean, any of these CEOs are welcome to call and correct me if I'm wrong, but it would seem like if you had a minor cybersecurity incident, it's probably a blessing because you're going to be okay. This did happen. This was scary. Now you're going to really take it extra super serious. Even if you already are, I feel like anytime something really happens to you, like you have a small break into your home, that really kicks you in the pants to be like, okay, this is for real. So who else can we bring in? What else can we do? I feel like everyone, when they have those little like life-threatening moments almost, that really like clicks things into place. I mean, Rosemary, how do you view this situation? I mean, is this just one of many that's going to continue to happen? I mean, do you think there could be any, like I said, a silver lining to like a small incident like this happening for a big company?
Yeah, I think so. I mean, I don't think it's really specific to any one company. It's something that any company is going to face. Everybody is interconnected. And I mean, if your response to this was like, okay, well, we're going to abandon the internet, then obviously that would be it would have a negative effect on your business.
The Luddites win.
Pretty major one. I mean, in terms of the manufacturing facilities, I think it's probably not as pervasive, although, being online and networked and everything, as you might think. I think there's still plenty of, paper instructions going around, like paper work instructions. And, I think that just because say that the whole network went down, I think that the factory probably would not immediately shut. I think it would have a more of a larger impact the longer it went on. But I would be surprised if everything just ground to a halt immediately and just kind of stopped waiting for everything to come back online.
Yeah, these cyber incidents are scary. And it's also interesting just to see the continuing evolution of cryptocurrency, because we know a lot of the anonymity that cryptocurrency provides has allowed a little bit of the rise in cybercrime. And I've been really wondering personally, just in the last year, whether cryptocurrency is going to come under any more regulation, or if they were going to outright ban it, just because it seemed like the number one currency of the underworld, right? But as of now, cryptocurrency is thriving, right? So companies just need to continue to batten down the hatches and do their best. But I'm sure we'll see, unfortunately, more of these. But it sounds like, on a positive note, that Vestas, it sounds like they caught it quick enough and it wasn't a major ransomware event yet. So moving on, Siemens Energy, their CEO, has talked about, just made some public praise of Siemens Gamesa Renewable Energy. Of course, Siemens Energy owns a 67% stake in Siemens Gamesa. And there have been talks earlier in the year about whether they would, complete that buyout and take out the rest or buy up the remaining 33%. Alan, do you think that's going to happen at some point, or what is Siemens Energy looking at to their, their little brother company?
I don't think they're going to end up buying the rest of it. That's a continual talk about it. But I think if you're just hedging your bets over this next couple of years because of the economic conditions worldwide, you want to leave options open. And my guess is that, Siemens Gamesa really wouldn't want it. Siemens really doesn't really want it either. In a sense, they're trying to be independent things, and for a good reason. As the push is going to be, and we're going to discuss here in a little bit, the inflationary pressure and the reduced margins that are happening in the United States and around the world and wind energy. And if you even just watched Vestas stock recently, there's a lot of plummeting value in wind energy, and it's going to be really touch and go for at least the next 6 months. So I think everybody's going to stay put, right? Hold your cards, try to weather through it, and then get to more stable territory where you feel like you can make some long-term cash. We're just not there yet.
In other news, Shell is taking a stake in the Simply Blue floating wind farm, which is off the coast of Ireland. Of course, this is not Shell's first foray into offshore wind. Of course, other companies such as Chevron have been, vocal opponents of the value of wind energy. So, but Shell has shown an eagerness to invest in it and work towards, the zero carbon footprint. Rosemary, what's unique about Ireland as far as offshore wind? Obviously, this project is looking at 1.35 gigawatts of energy. So this is not a small one. That'll power up to 1.1 million Irish homes. But I mean, this seems like a pretty nice piece of a pie to be a majority stakeholder in one of these really big offshore wind farms.
Yeah, I mean, it's a great area for offshore wind, and we're seeing a lot of development in that region. I don't know if that's a specific strategic goal of Shell to get in that region. I kind of feel like it's more of a global pattern of just in general, they're trying to get more into renewables. And it's actually, it's interesting because, you know, there's a lot of anger, maybe is the right word to say, amongst people, renewable energy advocates. There's a lot of anger towards fossil fuel companies for, you know, their role in causing climate change and then kind of delaying action on it. But then you see with Shell, they are definitely putting significant effort into cleaning up, whether it's because they feel it's the right thing to do, or probably, you know, more cynical, probably think that they just see that that's where the future money to be made is. And then, you know, like people still kind of seem to harbor some sort of resentment. It was interesting. There was another thing in another acquisition, Shell acquisition in the news this week in Australia. They announced that they're acquiring Meridian Energy, who own PowerShop, which is an energy retailer in Australia, a clean energy retailer. Well, they have this climate active certification, which you get if you're net zero for your whole overall business, and they supply electricity and gas to mostly to households and small businesses. And so it's really interesting because the customers of PowerShop, you know, have specifically gone for you know, net zero energy retailer, and a lot of them are really upset that now that that's owned by Shell. So, you know, on the one hand, they're getting their clean energy like they always have, but on the other hand, the business's profitability is now going to Shell, who's still a fossil fuel company in addition to the renewable stuff. So it's kind of raising some really interesting kind of political and philosophical points, I think. But for me, I mean, I think that the companies like the fossil fuel companies like Shell that aren't moving into renewables, I think they definitely don't deserve to be punished for it. Maybe, you know, they don't deserve any more credit than any other company that's moving in that direction now as well. But I think that the transition will go faster the more of these, you know, fossil fuel companies that, you know, get on board with the energy transition. And it does seem like Shell is doing it in a legitimate way. You know, investing in wind farms is different to, you know, like pushing blue hydrogen or something that still uses a lot of fossil fuels. So I can get behind what Shell's trying to do here, definitely.
Well, and you also wonder if the more a company like Shell invests in wind, the more they start to just like become a renewable company. Like they don't even realize they're doing it. It's just like maybe they're, I don't know, slowly killing that side of them, you know, by being profitable and successful in the other part. Maybe they, you know, they don't mean to do that, but it happens on its own. I don't know. I mean, Alan, what do you think of the implications here with Shell?
Well, I don't hold animosity towards oil companies that provided the lifestyle and the standard of living across the world that we enjoy today. I think those things needed to happen. Otherwise, we'd be living in an agrarian economy back in the 1800s. And I don't think that's good for society. I think there's a lot of things that energy has corrected in terms of making living more livable. The question right now is, do we make a transition to more renewables? And obviously, we're going to make that in a variety of different ways. We already are in so many ways, I think, in the way that the oil companies, quote unquote, oil companies are into natural gas more than they were 20 years ago. And they're reducing emissions on a lot of different fronts. The question, right, I think is, will more companies like Shell and be going into more renewables? Because Chevron, like you said, Dan, Chevron is not one of them, and so they're all going to play their bets down, and you know, only probably a handful will make the transition over if we grab more renewables, because these businesses are very difficult to manage, right? And they're taking billion-dollar risks every day, and some of them win and some of them lose. That's what's going to happen. But I do think Rosemary's right in this sense, that you're going to have to keep options open. You're going to see more changes, and particularly in wind, we're going to use more and more offshore wind because the winds are better. We're going to have bigger and bigger turbines, which means we have bigger and bigger risks. Every turbine, we're talking like 15, 20 million to probably put a turbine out in the ocean right now. Those are huge financial risks, and it's going to take companies like Shell that have the cash and the wherewithal to go do that. And we were taking some looks at Dan and I were just talking about this earlier today, taking some looks at who owns wind turbines in the United States. And what you're finding is you're getting larger and larger energy companies buying more and more wind turbine sites. So there's been, instead of this homebrew thing we saw 25 years ago, we have some really big players in wind because of the potential upside and the ability to generate cash and profit. Those are great things. And I think, Rosemary, you're right. It's that renewable energy is going to be profitable, which is going to change the industry. Because only if it's profitable, I think, can we really make the transition to a cleaner, less carbon dioxide society. Does that make sense?
I definitely think that it's at the very least makes it much faster. The energy transition can be much faster because it's profitable.
Yeah.
And I think that's why, I'm not like a diehard defender of capitalism, but I do think that is likely the fastest way to solve the energy transition is to, fix our system of capitalism so that it can solve the problem. So, get rid of this, failure of capitalism. Climate change is caused by a failure of capitalism because we didn't put any value on the atmosphere. So we need to fix that and then set things up so that, companies can make money off the energy transition. I think that will be the fastest way to solve the transition. So yeah, in this aspect, I'm definitely a fan of capitalism.
Yeah, well, let's talk about that for a second, because I think this is a very interesting point. Because where we go as a society is sort of based on these two arguments. I think a lot of the scientists and even the oil companies, I'll give them until the mid-1970s, early 1980s, before they really realize that they're changing the planet on some level. That's what I recollect, having lived through those time periods. So from early 1900s into the 1980s, let's call it, like there really wasn't a lot of discussion about climate change on a sort of a global level, right? I think there's a lot of well-intentioned people working in the oil and gas industry that are trying to provide a product which people want and makes lives better. That's all a plus. So now we're in this sort of punishment stage, I'll call it. When I see a lot of discussions about new types of renewable energies, one of the first things that the designer, creator, inventor, CEO will say is like, well, my technology will work, but I just need you to tax the living heck out of everybody else so that my product becomes the best one. Now that's sort of an anti-capitalistic way of looking at the world, but it doesn't make renewables better. It just puts a burden on the other side. And I'm not sure that gets you to the best solution overall, unlike wind, which has been making, I think, dramatic improvements in capabilities without so much of that.
I disagree a little bit, because I think that like a carbon tax or a price on carbon, it's not like a way to subsidize renewables. It's a recognition that there are actual costs of putting carbon dioxide into the atmosphere, not just, climate change, but also health costs and stuff. And we know about that. And so I think that normally you wouldn't get to harm somebody else without paying for it in capitalism. And so I do see the lack of a price on carbon as a failure. Like initially, up until like the 90s, because we just didn't realize the extent of what was happening. And then afterwards, because it's just been quite politically difficult. That said, like I almost never consider a carbon tax as any kind of solution now, just purely because of the politics. And Australia has had it worse than anywhere else. Like the word carbon tax is just like I hold 0% likelihood that we will have one in the next 5 years and probably 10 plus years in Australia, because it's just so toxic. And I'm so pleased to have been part of the technology revolution, over the last couple of decades that has seen that the technologies can make it on their own merits, even without making fossil fuels pay for the damage that they're causing. So, kind of both agree and disagree with you there on that concept of the carbon tax.
You're part of that change, though, Rosemary. I think you're part of that change, and everybody working at Vestas and at Siemens and Gamesa and Nordex and all the different wind turbine manufacturers are part of that change. And so we need your brains to be applied to these problems, because that's the only way you're going to get to that next level, because it's not just making the wind turbine, right? It's about making the turbine more efficient, costs less to manufacture, less to operate, more profitable. That's one of the things that a lot of engineers spend a lot of time on. And you were there, right? If you could have saved $100,000 on a wind turbine manufacturer, you would do that. No, why would you do that? Not because it produced less CO2, because it made the product more valuable. And I think that's, as engineers, that's one of the things we are constantly picking at is, I want to make this thing 0.5% better than it was 6 weeks ago or 6 months ago. And those are the kind of improvements that bright, smart people working hard at this are going to be able to do, that we just can't really predict the future like we think we can. And I do see wind and some of the other renewables, solar being one of them, are going to really dramatically change because of that, not because of carbon taxes.
Yeah. And I mean, I see a huge change since the start of my career when I was working on renewables, and it was just, a bunch of hippies that all thought that, we should move to renewable energy, even though it would, I didn't really even realize at the time that it would ever be the economically obvious choice to change to renewables. And the last few years, like say 5 or so years, you start to see people working in the industry that don't have that ideological connection to it. It's just, a business like any other. And it's made the most dramatic shift in the scale that's possible, because it's not just, environmentalists anymore that care about renewables. And so I've seen the power of, of the economics kind of, So I think that a lot of the really passionate environmental activists kind of think nearly like it shouldn't matter the cost, but it's not a moral reason that the cost matters. It's just the speed and the scale that you can reach when you have the economically best technology. Then, that's so powerful.
Yeah, I think that's where the power lies, right? And I think there's a lot of idealism at COP26. There's a lot of idealism that goes on there, but the reality is, the things that we want to get to, the state of carbon dioxide emissions that we want to get to, are really only possible through, in part, capitalism, and also the results of some parts of capitalism, which is really smart, educated people being able to devote time to make these things better. And that's sort of where we're in that sweet spot now. We ought to take advantage of it like crazy, because we can move to the next phase. And I think that's fantastic. I just wish some part of capitalism got a little bit of credit for that, and it doesn't.
I mean, I give it credit, but I also see that capitalism doesn't just happen on its own. You need to make sure that the market is set up right. So there are still some distortions in the way that energy markets run that are really set up to, based on the technologies that we had available at the time. And I do see that there's a lot of regulations and market-based stuff that's in the way of a fast energy transition. And so I would really like to see governments focusing their energy on cleaning that up so that capitalism could get the right outcome. That's what I would do if I was in government, which I never want to be. But
well, I think you're totally right about that. Removing some of the barriers that exist, Rosemary, is exactly the right answer. Removing some of the barriers that exist that slow down these projects, that slow down the development, are some of the places where governments can make a difference. Instead of adding more regulation in certain areas, we need to kind of step back a little bit and let some of these projects develop before we decide to regulate them to infinitum. And I agree with you there. So I think we're just at this really interesting precipice, particularly in the United States and around the world. So we'll see.
Well, doubling back to the cost of offshore wind, obviously it's difficult to install these. Like you said, it might be 15, 20 million per turbine. So Rovco, which they are a company of underwater drones, and one of their things is they have really good video quality. they shared on LinkedIn that they've been helping to identify unexploded mines and bombs from World War II that are in the bottom of the ocean that are potentially hazards for any new development, specifically, obviously, offshore wind. So this is something I think people don't think about enough, that there's still a lot of ordnance that can explode. And I'm curious what they do with these, if they have to detonate them or if they're really going to pull them up to the ship. It's like, yeah, don't bring that in here. We don't want that. But I mean, Alan, what do you think they're doing with? Obviously, there's some photos from them, which is a cool article we'll link to. But they clearly have pulled some of these up to the boat. But
wow,
do you know much about unexploded bombs and mines and how they dispose of these?
I think they would explode them, right? I think in the past they used to explode them. Obviously, after World War II and a lot of other conflicts, there's been mines in the Strait of Hormuz and a bunch of other places where there's been mines. But a lot of them are kind of magnetic mines that are sort of moored to the bottom with a chain that are maybe a little bit easier to go get and locate. Some of these World War II pieces are just basically aluminum shells that are dropped in the bottom of the ocean and are really hard to detect. And I think the trouble is that we're going to be putting a lot of equipment, cables, disturbing the ocean bottom, probably more than we ever have in human history, besides when we were dragnetting the bottom of the ocean for fish or whatever, that we're going to come across these World War II-ish mines. I don't even think Europe is the only place we're going to find them. I think we're going to find them off the coast of the United States in some places. I think off the coast of a lot of islands in the Pacific, we're going to find things like this that is going to be hazardous duty. And Rosemary, I don't know what you're going to be able to possibly do to find all these things. I don't even know if there's any record of where they were planted.
Well, not a public one anyway. I mean, I wouldn't make that public if I was involved. But I mean, drones is the answer, right? I mean, how else are we going to be able to map all these areas?
So are we going to go map the whole? I guess we are. Are we going to go map all the locations where the cables may run and where the turbines would be? And are we going to have to scan the entire floor of the ocean before we move forward? Wow.
Probably.
Wow. That's a big task,
well, I mean,
guys.
In the sites that you're proposing to put stuff, yeah. Otherwise, stuff's going to get blown up, isn't it? But I mean, it's not just mines that you're looking for. You're also looking for, like trenches and I don't know, other weird stuff. So yeah, I mean, you got to have at least a decent understanding. Yeah. Well,
Dan, as if you're talking about putting wind turbines essentially from Georgia all the way up to Maine in the United States, that's a lot of coastal areas that's had a lot of warfare along it throughout the ages. I even during World War II, I think there were Nazi submarines in New York Harbor. So who knows what's out there? I can't imagine trying to scan all that territory. But Rosemary, you may be right. They may have to go scan that territory before they go out there, just to make sure that there's nothing out there that could be treacherous or dangerous or explosive. Wow.
Yeah, I mean, I hate to say I told you so, but this lends more and more credence to my bringing Godzilla back to life. He could step on all of these. It's not going to hurt him. Like, come on. He'll be totally fine. It is a really fascinating problem, though. I mean, to think that, and such a scary thing that you could be laying subsea cable and your operation just blows up. I mean, from a huge, it's crazy.
Wow.
It's a really interesting thing that people aren't thinking about, but there is a lot of stuff out there. So let's switch to North Dakota. Obviously, we know this happens. We know that wind turbines, they have to get shut off and the blades feathered in really high wind conditions, but I just don't think you hear about that much. But up in North Dakota right now, they've had wind gusts as high as 70 miles per hour. Rosemary, when is typically the cutoff point? Is it around 60, 70 when they start to need to shut turbines down to prevent them from getting out of control and destroying themselves?
Are you trying to make me think in miles per hour now?
No one thinks in kilometers except for the whole world.
Try meters per second. That's a nice engineering unit. I don't know. This reminds me because I studied in the US for 1 year. I studied at UC Davis, and I did all their aerospace engineering units while I was there. And engineers, for the most part, do prefer the metric system. I think that I mean, nearly exclusively. Everything works. All of your equations just work out without any gravitational constant or something. So, you know, like all through the semester, you would be doing all of your examples in the metric system. And I got into an exam, and I think it was literally in jet propulsion, so effectively rocket science. Read this question, and it had the word slug in it. Like, that's a unit. I had seriously never even heard of that as a unit, let alone was supposed to know what to do with it in an exam. So I had to put my hand up in the exam and ask the professor what a slug was, and the whole exam hall just erupted in laughter because it was like a final year aerospace subject, and I didn't know this unit. So anyway, I won't be answering a question in miles per hour, but obviously every wind turbine has a cutout wind speed. It's written on the brochure. It's not a surprise. It's not a secret. It's not something we're trying to, like sneak in without letting anyone know. And I guess what I would say to like the average person on the street that's not an engineer, why it's like that. We could make wind turbines that could withstand higher wind speeds, and it's a matter of economics. Do you want to pay more for all of your wind so that you can capture this extra little bit, because they choose every parameter so that it ends up in the lowest cost of energy overall. It's kind of like, do you build all your dams twice as high as they currently are so that you have like a tiny bit more energy security? Do you build your hospitals with twice as many beds and twice as many emergency doctors just sitting around waiting for like the once in a century pandemic or whatever? It's just an optimization, and if you gold plate everything, then everything costs more, and then like obviously you spend more on your energy, then you've got less money to spend on food or whatever. So it's just a really normal kind of not just an engineering problem, like anybody that's building anything, any product, you have to decide to where your boundaries are.
I was looking at the US maps for wind speed, and off the eastern shoreline, the wind speeds are really high, much higher than they are on land. Do they require a completely different kind of blade and a completely different setup in terms of the style, the structure, how it's designed, because its average wind speeds are just higher?
Well, I mean, you're gonna take there's a whole range of load cases that you need to design. Like, let's talk about blades, because that's the what I know, but every other component will be similar. So there's a range of different wind conditions, and one is like your maximum wind speed when it's actually producing power. What are the loads under those conditions? And if you want a higher cutout wind speed, then you're going to have higher loads, and you're going to have to add more material to withstand those. Then there's also other ones that you don't have any control over. Like, you can't choose the maximum once in 100-year wind speed, and that you have to be able to withstand regardless of what design decisions you choose. So, you'll know what's the maximum wind speed we see, a maximum gust that we see at this site. You have to design for that. But that's with the blades would be feathered out of the wind. So it's not necessarily the hardest load case to withstand. So to answer your question, some of them you have a choice over, and some of them you don't have a choice over, and all of them affect how the components are designed.
So the hurricane case, which is pretty much the whole eastern seaboard of the United States, so you're going to have this design speed you're aiming for, and it's going to be a normal operation where you're generating power. So if you do get those 60, 70, 80 mile an hour winds, you just go straight to feather and braking?
No, they usually idle these days.
Or just let them idle. Okay.
Yeah, like in the past, they used to brake them, but it's actually easier on the turbine and also on the bearings, especially if you let them idle, because the bearings hate to have like a strong load when they're stationary. You cause flat spots. So usually you're not braking as like an operational kind of regular thing.
So these wind turbines up in North Dakota were braked, though, Dan. That's really interesting, because what Rosemary's saying is as these wind turbines, as they're figuring it out now, it's probably not a great idea to brake them, as maybe just to feather them and let them spin slowly. That's interesting. I wouldn't have guessed that.
And it will depend what the turbine is designed for, obviously. And I mean, I couldn't say categorically that none of them today are designed to actually break in strong winds, but the ones I've worked with are feathering. I did want to add one other thing. When they build or plan a new wind farm, they do check the loads for that site. You know, it's not just that you make a wind turbine, you certify it, and then you put it in wherever you like. They are checking it for the site that they're going to. And sometimes it may be the case that you've got a really big, nice, profitable wind farm, and the loads are just a little bit higher than what the blade's designed for. You might go through and add a couple of extra layers of glass or carbon fiber to be able to withstand that. If it's worth it, you know, if the business case is there to go through the change, and you have to make you don't go through the whole certification process again, but you would probably, you need to get that new blade certificate. So you'd say it's very similar and we've made these changes and this is, you know, why we're sure that it's going to be okay. Otherwise, your option is to just, you know, reduce the loads on the, on the turbine. So, you know, you might reduce the cutout wind speed or something.
Sure.
Yeah.
So they are tailored to each site a little bit, or they can be.
Yeah.
Wow.
If the site's big enough, then they are. They have to check every site. You can't ever put like you wouldn't get a certificate. The developer and the developer's insurance company especially wouldn't be happy without a certificate that was based on the conditions, the local conditions. Yeah, but whether or not you're actually going to make a new design for that site depends on the business case. If it's a big profitable wind farm.
So we're going to shift and talk about microgrids. We're definitely going to lean on Rosemary here. Interesting article from Clean Technica talking about basically a projection that microgrids might generate 500,000 jobs and 72 billion in GDP growth by 2030, which is, you know, about 8 years off. Rosemary, fill us in real quick just on the basic definition. What is a microgrid? Where are they popping up, and why? And why? What do people need to know about it, and why should they care?
It's bigger than you'd think. It's not like 2 solar panels and a battery as a microgrid. It's more like you know, like a small an island or a small community. A grid, like a normal grid, is a huge thing. So to be micro relative to, you know, like the whole of the east coast of Australia is, you know, there's a lot of space in between household, off-grid household, and yeah, like the east coast of Australia's grid. So microgrid, let's just say it's basically not, it's not like a normal utility grid with all these really huge power generators, like a fossil fuel power generator, or a lot of them connected together.
So enough for like a college campus, hospital system, small community, all those would qualify as microgrids.
Yeah. And I think a little bit bigger than that as well. And so in the past, they've mainly just been used for places where it's not economic to connect it to the normal grid. And I think Australia has a lot more of them than most places, because we have, you know, a very spread out. There's a lot of communities that are a small community, but they're 1,000, or maybe not thousands, but like 8,000 kilometers away from a real grid. And so, you know, you just can't lay enough power lines. It would just cost too much to connect them. So we've always had microgrids, and they've usually been heavily reliant on fossil fuel generators, like diesel generators. And as soon as solar panels kind of started to get cheap, a couple of decades ago even, that was like the first place where you could really see the value in them, because they're directly displacing diesel. And I think most microgrids today still have some diesel in them, but they are more and more becoming just solar panels and batteries for, you know, the majority, and the fossil fuel as a backup. And less commonly wind, but I think we'll see more of that. And I think what's interesting about microgrids now is that people, now that all the technologies are kind of cheaper, so there's not like a big economic reason not to do it, people are starting to see some of the other benefits of a microgrid. And I talked a little bit last week about how in California they want to be able to operate they're all grid connected, but they want to be able to operate in island mode, which is, you know, effectively operating like a microgrid when there are, you know, like bushfire conditions. So they would have to, you know, turn off power lines in case there was a fire. So there's a lot of benefits to a microgrid. even if you don't have to have one, just, because of the logistics of connecting to the grid.
Alan, do you really think that this is going to generate that amount of jobs in an 8-year period? I mean, I don't know if that's really that many jobs in 8 years. 500,000 always seems like a big number, but it might not be that big of a number globally, really.
Yeah.
I mean, where do you see microgrids coming in to play here?
Well, the question about jobs in renewable energy is always a catch-22, I think, because as Rosemary and I were talking about earlier, you're trying to drive down the cost of energy. And if you have to continually provide maintenance to it and put a bunch of people on it, it just drives up the cost of energy. So a nuclear power plant, you would hope, has very few people in a sense relative to thousands of individual wind turbine sites or individual solar sites. That's why you see this sort of conglomerate happening now in terms of wind, where you have one major operator running gigawatts of power because you can just do it much more efficiently, which lowers the cost of energy down. So I think it's a real odd trade-off to say, well, the microgrids are awesome because it's going to create a bunch of jobs, but that's just going to raise the price of energy also. So you have to find that really funky balance between what is minimally needed and what the advantages of the system are. And I'm not sure California's really figured that out. Or in terms of a large state in the United States, maybe Texas, because they've got their own, and Texas is a huge, massive state, right? But they don't interact with any other surrounding states on their power grid. They're their own little island there. So maybe they're really the place where you could actually ask the question of, are smaller grids, and because Texas is kind of west and east and south a little bit, are there advantages to that, and does it really need that many people to maintain it? That's a great question. I think I would like to see renewable energies just be more efficient overall, and having microgrids I think makes sense, but they should be much more resilient and reliable than what we're proposing right now.
And so how will these figure into this whole ecosystem of energy storage, energy production? I mean, do microgrids, Rosemary, need more batteries? Do they not need anything different than a full-size grid would have? Well,
so a microgrid is small, right? And it's geographically small as well. So with variable renewables, like especially wind, the further apart that you can put your wind farms, the less variable it is overall. And same with solar. If you can connect them east to west at least, then you'll get solar power over a bigger period. So a microgrid doesn't have that benefit of geographic dispersion, and you may also see your demand more kind of correlated as well. I guess it would depend what kind of a microgrid it was. So in some ways, like the smaller the grid, the just more you kind of concentrate than just the regular challenges that we know about already with adding a lot of variable renewables to any kind of a grid. So energy storage is a really important part. And I think especially the cost of lithium-ion batteries have come down so much in recent years. And I think that's probably been the number one biggest thing that has impacted on making microgrids a viable solution for a much larger range of people than, 5-10 years ago. It was purely if you were forced to do this. That would be the only reason that you would. Whereas now it is starting to make sense because of the other benefits that you get. Like the reliability is not inherently better in a microgrid. It's probably, harder to start off with. But when you change your normal grid, when you get more distributed energy and add the capability to run in, little islands, then that gives you the opportunity to add resilience to the grid. So I think it's pretty complicated, actually.
It is.
Yeah, like it's not like building microgrids is definitely going to increase or definitely going to decrease reliability. But there's the potential, if you do it right, to increase reliability, to bring costs down, make everything more renewable. But you do have to do it right to get those benefits.
And then let's transition into the supply chain crisis that has been quite a bit in the news cycle recently. Obviously, to make any of this stuff happen, whether it's new technologies getting adopted, whether it's battery prices coming down and becoming ubiquitous, all these supply chain issues are going to really come to a head, whether it's materials, whether it's shipping, logistics, all these different things. They're, supply chains have been pretty screwed up recently. Obviously, we've seen inflation go up as well, and depending on where geographically things are located or where they're manufactured, that's also another major player. This is why you're seeing more and more companies partner up, trying to, whether it's doing a mining operation or control shipping costs, whatever it is. Alan, how do you see all these things tying together? The energy storage, the microgrids, some of these new technologies that maybe need to mature to make both of these things also mature. How does this clean energy crisis of logistics, how does that continue to play out, and what do you think is going to happen with it?
Well, I think the big variable is time. I think eventually we're going to get to the spot we want to get to. The question is, when we put shortened time frames on it of having everything working in the United States on the East Coast by 2030 in terms of like offshore wind, there's a lot of infrastructure that has to happen and a lot of dollars that has to be poured into that infrastructure and having people to be able to go do it. It's going to take several years to get to the point where we're actually getting up to speed. This is a bigger, this 30 gigawatts off the coast of the United States is like a space program. If you remember, well, none of you were alive then. I was barely alive then when the Apollo space program was, and how many people it took to go do that. And you're talking about roughly, 7-8 years of just like intensive work to put 3 men up and around the moon and two to land on the moon, right? And bring them back home. That was a tremendous effort. And now we're talking about basically building infrastructure projects all up and down the East Coast of the United States and having all the materials, the raw materials, and the capability to make those materials and the technology to make those materials and the people to ship those materials all magically appear. That's not realistic. And I think that the states that are sort of more tied into that, like Texas, and I think North Dakota, because North Dakota was in the middle of building a pipeline not very long ago, they realize how difficult those things can be. And yet when we talk about expanding renewables, we seem to forget about all the other components that have to happen for it to become reality. So the real key issue here is time. Giving a little more time, it takes some stresses off. You'll probably actually spend less money to get some of these projects up and running. It's a question of right now of political will, because I don't think today the U.S. can pull off what we're trying to make happen. And this is the whole political. 2030 sounds nice, right? It has a nice ring to it, 2030. But if it's 2031, is it all that bad? I don't think so. Or 2034, it's not terrible, right? We're still going to get where we want to get to, and we can do other things in the meantime. But I just really struggle with thinking that the U.S. can turn around and create some of these industries in such a relatively short time frame. I think it'll be really difficult to do.
Yeah, anytime you see round numbers like 2030, 2040, 2050, like that's just a sign that it was pretty nice rounding to call it that number. I mean, are we going to continue to see a pinch of materials? Like, I mean, some of these materials that are maybe a little bit scarce now won't necessarily be scarce forever. When we develop new mining techniques, new mines, maybe you find one that really, really hit pay dirt. I mean, a lot of these problems will probably be alleviated just through, I don't know, continued effort and happenstance. Rosemary, what do you see here for this supply chain crisis? I mean, is this really just kind of like the riding the coattails of COVID? Because it just seems like the last 2 years have been messy in general, and that life might kind of get back to normal a little bit. I mean, what do you see from this?
I think there's two different kinds of supply chain crisis, and one is just related to the time we're in now, and it affects every industry and any kind of product that you want to get from one place to another. It takes longer now than it used to, and there's some specific crisis points like with computer chips and stuff. But I think the more relevant stuff for renewables is around certain minerals. Like lithium and rare earths and a few others. And I think with most of those, there's some of those are legitimately scarce and only available in a few places on Earth. And so those are going to cause challenges, but mostly those are things that you can get away with not using by just, moving technology in a different direction. Like you don't have to use that much cobalt. Even in a lithium ion battery, you can move to different chemistries that don't rely on it. And I think that will happen. But then a lot of the other things like lithium is not a scarce, is not scarce. It's everywhere in the world. And, the US has plenty of places where you could start to extract it if you wanted to, if, the price signal was there and the political will as well. And I think, it's illustrative to look at the example of solar cells. They're using silicon, and they need polysilicon, which is made mostly from sand, basically from quartz. So a very abundant thing. It was mostly used in electronics until the solar panel boom started, and then suddenly the demand was really all of a sudden the demand was much higher than it had been. The price went massively up. A bunch of companies saw heaps of money to be made off this, huge price for something that's made from sand. And I don't think that the process is that complicated. You need energy and you need sand basically, and then you can make polysilicon. So then you saw, this huge rise in companies that wanted in on that, saw the price crash. And now we've got some more uncertainty on that. It's mostly made in China now, but there's no reason why other countries can't make their own. It's just about whether or not you value making something locally for the security of that versus cheap prices buying it from China, who have already figured out how to make it cheaply. They're the companies that have put their effort into learning how to make it cheap. And same with lithium. I mean, it mostly comes through China, but they're not mining it there. The actual resource comes from other places. And if you want to have security in that, then most countries could, but it's a trade-off between the cost and the security. And so I would expect that we'll see a bit of both into the future. You start off with some local, relatively expensive options, and gradually, as those get better and cheaper, then you'll see the balance shift. And I mean, I personally hope that we do move to more local production of things like this in the future, partly because some of these minerals are environmentally harmful to mine at the moment, and so especially with rare earths, there is rare earth mining in the US in Nevada, and it's easier and cheaper to get it from a country that doesn't care about the environmental impacts of it. So I would like to see it move to countries that do, so that we don't have these environmental impacts. And also, obviously, the more that you produce locally, the less shipping there's going to be, and shipping is one of the hard things to decarbonize. So I kind of see us moving away from globalization for a combination of all those trends. We'll see less of it. We won't see no globalization, but we'll see, I think, less.
All right, so we're going to transition to our last thing today. Get Rosemary all fired up before we depart for the holiday here, because it is Thanksgiving weekend here in the U.S. Rosemary, seaweed-inspired underwater power generation.
The future of renewable energy.
Article from Fast Company. Yes. It wouldn't get eaten by any animal at all. What do you think about this? Obviously, people are pushing the envelope, trying to develop new technologies to harness different types of power from the earth. And obviously, we had Glenn Ryan, founder of Bombora Wave Energy, on the show. Is seaweed power, this other company, this new technology, is this going to be something that we see in the future?
I think we'll see it in a lot of YouTube videos and science shows and stuff. People really like anything biomimetic and mimicking nature. Don't get me started on all the other kinds of nature-inspired solutions that they're cool. It's interesting, and I think that this research is interesting. And I looked at it and I'm like, oh, that's so cool. There's this seaweed-like thing, and it's gently floating back and forth, and it's generating enough electricity to power some LEDs, which, as we all know, need practically no power to run. I made a wind turbine out of gingerbread that could power a string of LEDs. So I will say that that's not a high bar to reach with a new renewable energy technology. I think it's cool and it's interesting, but what I would like to see journalists when they're covering this sort of story, what I would like to see them ask questions like, does this address any of the real issues that are currently causing problems for more advanced technologies? So, I mean, this is kind of funny because usually I'm looking at wave energy and saying why that is unlikely to, be a solution for the energy transition. And then this seaweed thing, it's like an immature version of wave energy. So wave energy is like the big wave, mature technology in comparison. But like the main problems with that are, reliability, cost and maintenance. And this technology is clearly going to be worse on all fronts there. So, I don't see the potential to develop it as even when matured, I don't see that this would be, a major part of the solution. I think that you direct your energy, continue to direct it at wave energy if you really want to get energy from the ocean, also tidal. And then the other point is that, it's geared around harvesting this energy from gentler waves than normal ones can harvest. And this is really similar to what we see with, like urban wind, and every new small wind turbine design will tell you, it harvests energy at low wind speeds. And the fact, like the way that energy works is that there is less energy in low wind speeds. There is less energy in gentle motions. Like if something is just like kind of like gently moving back and forth, like just gently feeling, a bit of a sensation on your skin, or, like if you're out in the sun at the North Pole and, like you don't really feel it, that's a sign that there's not much energy there to be converted, and that is not the place to focus your energy because you're just really self-handicapping. So, yeah, I would like to see people more critically like look at these kinds of aspects of a new technology before coming up with a headline that, this thing is the future of renewable energy. That doesn't mean it's not cool. Like it's still a cool thing. It's just not going to be part of the energy transition.
All right. Well, that's going to do it for this week's episode of the Uptime Wind Energy Podcast. Thanks so much for listening. Be sure to subscribe on iTunes, Spotify, Stitcher, YouTube, wherever you listen or watch. Be sure to subscribe to the show and definitely sign up for Uptime Tech News and Rosemary's YouTube channel, both of which you'll find in the description or show notes of this podcast. Thanks again for listening, and we'll see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.